Hi students, in this video we're going to explain about the impulsive force and we're going to then discuss a little bit about collisions. What is an impulsive force? It's a force that is acting during a very short interval of time. You graph force versus time. In the case of an impulsive force, you're going to see how the force, the magnitude of the force increases very, very fast, but also after reaching the maximum point here, it's going to decrease very fast. To try to use, the actual value of the force would be really hard because the force is changing very quick and it's very hard to measure, that magnitude. So in problems involving impulsive force, we're going to use to solve the problem one force that we call the average force. How we find this average force? We're going to say that this average force would be equal to the variation in linear momentum, delta P, divided by delta T, by the divided by the interval of time. So what is linear momentum? The linear momentum of an object is the product of the mass of the object times its velocity. So if we have a variation of linear momentum, we have a variation in the product of the mass times velocity of this object, right? Divided by the interval of time. The mass is constant, so the mass of a car is not changing, before and after the collision. So what changed here is the velocity. So we can say, that this variation in linear momentum, there is the variation of the product of mass times velocity would be equal to mass times final velocity minus mass times initial velocity divided by the interval of time. So this is the formula we can use to find the average force. There is acting during a collision. So let us see this case. Let me explain why a negative sign here. This is our rectangular coordinate system. So the x-axis is positive to the right. We have a car that is moving to the left with a velocity of 10 meters per second. There is a wall here, and the car is going to crash against the wall. And after the impact of the car against the wall, this car is going to rebound. The velocity when the car is just going toward the wall is 10 meters per second. Now we are taking this value negative because it's against the direction of the x-axis. Once the car just impact the wall and rebound, it's going to rebound, of course, with a lower velocity. Let us say that the velocity in this case is 1.1 meters per second. The time of the collision, let us say that is in the order of 0.060 seconds. So we are talking about less than 1/10 seconds, So it's a very, very short interval of time. A second by itself is a short interval of time, but just when we're talking about 6/100 of a second, it's a very short interval of time. So these are arbitrary numbers I'm taking, I didn't measure any collision to prepare this exercise, but just these are values that we can use to illustrate what happens here. So let us say that if we want to find the force, the impulsive force that was acting here during the collision, we can say that is the mass of the car. Let us say that this car has mass of 2,000 kilograms. Let us say that this car is a car with 2,000 kilograms. Okay, so we say 2,000 kilograms times the final velocity. The final velocity is the velocity after the collision. So times 1.1 meters per second minus, and now we have again the mass. If you want, you can just take the mass as common factor. So you can say mass times final velocity minus initial velocity. So we can do like that also, right? Or we can just keep both terms apart. So I can say here 2,000 kilograms times 1.1 meters per second. That is the final velocity minus the 2,000 kilograms times negative 10 meters per second. All this divided by 0.060 seconds, right? That was the time of the collision. So now we're going to say, okay, let me factor 2,000 kilograms out as common factor to make easier my calculations. So I'm going to say 1.1. Negative times negative is going to be positive, so plus 1.1 meters per second. We always put the units. Remember that in physics, when we have a number, like velocity or mass or any physical quantity without units becomes meaningless, right? So that's why it's important always to use the units. So we have 1.1 meters per second plus 10 meters per second, because negative to negative become positive. All divided by 0.060 seconds. So now we say this is 2,000 kilograms times 1.1 times 10 is 11.1 meters per seconds, divided by 0.060 seconds, right? So now we're going to multiply 2,000 times 11.1. So let me get my calculator here. So 2,000 times 11.1 this will be equal to 22,200. So I have 22,200 here. Kilograms meters per second divided by 0.060 seconds. So now we're going to divide, and when we divide those values, so 22,200 divided by 0.060, this will be equal to 370,000. So we're talking here about 370,000 kilograms meters per second square, right? Because this second multiplied by this second here becomes second square, and kilograms meters per second square is the same as Newton. So we have here 370,000 newtons. So we have 370,000 newtons. If you want to write this as kilonewtons, you know that in 1 kilonewton you have 1,000 newtons. So you can say that the average force here is 370 kilonewtons, right? There is exactly the same thing, that 370,000 newtons. So this is how we find the impulsive force, right? In this case, the force acting, during the collision of this car with a wall. Remember that this really is the average force. This is really the average force, because to measure the actual force acting would be very hard, because it's acting in a very short interval of time, right? So we better use the average force that we can relate with the variation in linear momentum. Well, thank you for your attention with this video.